Hi, hello, good evening, my dear students. Welcome back to my YouTube channel, Kayaka Maths Classes. So, in the last class, we have already discussed important definitions of group as well as Abelian group. Okay, so if you did not watch my previous video, please go and watch so that you can easily solve the problems on Abelian group. Okay, so we need to understand the 5 conditions which should satisfy to say that it is an Abelian group. Let us see this given example. So what he has given is, if a star b is equals to a plus b plus 3 for all a and b belongs to z, where z is a set of integers, and what we need to prove? We need to prove that z comma star is an Abelian group. So here, my dear students, we need to prove that z, that is a star b, is a given function, that is binary operation, and we need to prove this binary operation on the set of integers which satisfies the Abelian group, which means we have 5 properties to be proved. Then we can say that the given is an Abelian group. Okay. Let us start one by one. Okay. First one, let us take the 3 elements a, b and c are the 3 elements which belongs to the integer z. Okay, now let us solve or simplify or prove one by one. First property is what? Closure property. Okay, closure property, you know already these things. First property is the closure property. So what the closure property says, let us take a comma b belongs to z. So this implies the combination of a star b should also belongs to z only. So a star b he has already given here. Here you can see a star b is nothing but what? A plus b plus 3. So a star b is an binary operation whose function is given by a plus b plus 3, which is the operation between the two elements a star b may be a plus b plus you just add 3 to it as of the given here. Okay, so this also belongs to z, isn't it? So therefore what we say, closure property is satisfied. Closure property is satisfied. Closure property is satisfied, isn't it? So how it is satisfied? You can take a and b as any numbers, my dear students. A and b as any number. If I take a as 1, b as 2, it becomes 1 plus 2 plus 3. Again 1 plus 2 plus 3 becomes 6. 6 is an integer. If you consider a and b as any integers, if you substitute here, you will get an integer value again. So that is why the first property will always satisfies to every example. Okay. Now the second property what we have? Yes, already you know this, right? Associative property. Second one is associative. Okay. So for this we need 3 elements. Let us take a comma b comma c belongs to the integer z. Okay. Now what is the associative property we need to prove? So a star b star c is equals to a star b star c. Let us see one by one. So now let us consider the LHS, that is a star b star c. Okay, now first what we need to do, first you need to simplify the bracket, my dear student. A star b. So what is a star b? Here it is, already we have used a star b in sense a plus b plus 3. Okay, and I'll write this star c as it is, this star c as it is. Now we need to apply this binary operator until the star, that is binary operation, eliminates. Still we have the binary operation here. So we treat this whole term as a star, this as b. So what we are doing? Addition of these two plus 3. What is given? A star b is nothing but what? A plus b plus 3. You just add these two and addition of the element 3. The same thing here. This is a and this is your b, and star operation. You just add them again, additionally add the number 3, that is plus 3. So it becomes a plus b plus 3 plus c as it is. So this is a, this is b. So a plus b plus function 3. So what this becomes, my dear students, a plus b plus c plus 3 plus 3 becomes 6. So this is our a star b star c operation. Okay, let us say this is equation number 1. Okay, now similarly we have to simplify the RHS. What is RHS? A star b star c. Now I'll keep the a star as it is because I just have said you need to simplify the bracket first. Okay, so again b star c in the sense what, according to the given, yes, b plus c plus 3. Just add the two variables and add it by 3. Why we are using the same? Because he has defined in the given example only. A star b is nothing but a plus b plus 3. Okay, whatever the function may be. So here b star c in the sense b plus c plus 3. Again, as of the previous condition, this is total one term. A star, this whole bracket as b, whole bracket as b. So what we need to do, again using the same given property, add them, a plus b plus c plus 3 plus 3. Why 3? Because he has given here. Just add the two variables and plus 3 additional he has given. We are using the same here. Okay. So again what this becomes, my dear students, a plus b plus c, again 3 plus 3 becomes 6. Okay, so let us take this as equation number 2, and you can observe if from equation 1 and 2 both are same. Okay, from 1 and 2 what we have, a star b star c is equals to a star b star c. Therefore what we say, associative property satisfied. Associative properties satisfied, and these are the two properties which are satisfied. Now the third one, what is the third one? Yes, identity, existence of identity element. Existence of identity element. So you should remember the condition, my dear students. Okay, a star e is equals to e star a is equals to a, where e is the identity element. Okay, let us consider the first one. Okay, and you can consider any one among either a star e or e star a. So a star e is equals to a. So again a star e is nothing but what, it is like a star b only. What is our property? Function says add them and additionally added number 3 is equals to a. So a star b, it is like a star b only, a plus b plus 3. Instead of b we have e. Okay, now we need element e in the sense just transfer these two into RHS. What this becomes, e is equals to a minus 3. Okay, so you can cancel plus a with minus a. What is the remaining term here, my dear students? E is equals to minus 3, isn't it? E is equals to minus 3. Therefore e is equals to minus 3 is the identity element, isn't it? Therefore e is equals to minus 3 is the identity element, which means the identity element exists. So this property is also satisfied. Now existence of inverse property. So what is the condition for this? A star A inverse is equals to A inverse star A is equals to E. Let us consider first one. Okay, A star A inverse is equals to E. Again this is A star B. Instead of B you have A inverse. Let us apply the same function. Here it is. Okay, just add the variables, that is A plus A inverse, additionally add 3. Here you can say A plus B plus 3 is equals to E. Okay, now you need A inverse in the sense you can transfer this 3 and A into the RHS. What it becomes? A inverse is equals to E as it is. E as it is minus A minus 3. Okay, so A inverse is equals to, so you need to use the E value here. E value we just obtained here in the previous condition only. Here it is. E value is minus 3. So let us take this as equation number 3. So E value is minus 3, I'll use here. Okay. Minus 3 minus A minus 6 because of equation number 3. Okay. So this value I have used here. Okay. So what this becomes? A inverse is equals to minus A. Sorry, I have written here. It is 3 only. Okay. Now minus 3 becomes minus 6. So this is your A inverse value, isn't it? Minus A minus 6. One last property, that is commutative property. One last property, that is commutative. So already we know if the 4 properties are satisfied, then we say it is a group, simple group. If the 5th property is also satisfies, then we say it is a abelian group. Okay, we have discussed the definitions in the previous class. So what is the condition to prove here? Okay, let us take A comma B belongs to Z. So this implies first what we need to prove, A star B. A star B is again directly given in the example, A plus B plus 3. So let us take this as equation number 4. Now the next part is B star A. Okay, commutative in the sense we need to prove A star B is equals to B star A. So instead of B we have A. B has changed to BA. So how will this becomes B plus A plus 3. Okay. So B plus A or A plus B both are same. So I can rewrite it as A plus B plus 3. And I'll take this as equation number 5. You can observe 4 and 5 are same, isn't it? Therefore, from equation 4 and 5, what we have? A star B is equals to B star A. So therefore, commutative property is satisfied. Now all the 5 properties are satisfied, my dear students. If all the properties are satisfied, then we say that hence Z comma star is an abelian group. Okay, isn't it easy? Isn't it easy, my dear students? With simple steps we have proved the given function is a abelian group. Once again, just look into just for 1 second. So closure property, associative property, identity element, inverse, and the last one is commutative. If all 5 are satisfied, then we say that Z comma star is a abelian group. Okay, please watch my previous class also. You can easily solve this problem also. Okay, it depends on the purely definition of a group as well as definition of the abelian group. So I hope you understood this. So I request my dear students, please subscribe to my channel, like, share, and share this with your students of your class and friends. Okay, thanks for watching the video. See you in the next class. Bye bye.